Okay, this is lesson 5.6, and in this lesson we're going to factor perfect square trinomials and difference of squares. These are our special products if we look back to lesson 5.2. And if you remember, if we looked at two brackets that were identical and squared them, we ended up with this pattern of an a squared term with a b squared term and a 2ab in the middle. And if we expanded two brackets that were almost identical, just with opposite signs, we ended up with only these two squared terms. So the question is, how do we use this to go backwards? Well, let's start with difference of squares. I put this note here. Always look for a common factor first when factoring a trinomial. Realistically, it's not just when factoring a trinomial. So let's change that to when factoring anything. We should always look for a greatest common factor. So let's try one of these. Let's first be able to identify a difference of squares. Now, I kind of spoiled it, but in example 1, all three of these are difference of squares. So to identify a difference of squares, identify a difference of squares. We have to have two conditions. Two terms that are perfect squares. And what's that mean? Well, that means you can square root them. And two, they're separated by a negative sign. That makes it the difference. So a difference means subtract, and squares means that they're perfect squares. So we can square root them. So let's look. X squared and 36. They're separated by a minus sign, so that's good. That's a difference. And are they squares? Well, if we square root x squared and if we square root 36, what do we get? Well, if we square root x squared, we get x. And if we square root 36, we get 6. So x and 36 become pretty important. X and 36 become your terms that complete your binomials. Because remember, when you factor, you're looking to create your two brackets, and something has to go in those two brackets. Well, it's x and 6 that go in. But what sign separate them? Well, if we remember, a difference of squares is the result of multiplying almost identical brackets just with opposite signs. So opposite signs fill the brackets, plus and minus. And if we want to check this by expanding, we can do x plus 6 times x minus 6 to show that this will work. X times x gives us our x squared. X times minus 6 gives us our minus 6x. 6 times x gives us plus 6x, and plus 6 times minus 6 gives us negative 36. And there's our middle two terms. We get 0, x squared minus 36. So we can check by factoring. So the key to factoring difference of squares is square root your terms, write them in your brackets, and put opposite signs. Let's try one that's a little bit more complicated. 16a squared minus 81b squared. Well, let's square root them both. 16a squared and square root 81b squared. Square root both parts. 16, the square root is 4. A squared, the square root is a. 81, the square root is 9. B squared, the square root is b. So we got 4a and 9b. Let's make our two brackets. 4a, 4a, 9b, 9b, opposite signs, plus, minus. Doesn't matter which one we write first. It can be the minus before the plus, doesn't matter. And factoring a difference of squares is as simple as that. Square rooting, writing the terms in, opposite signs. Last one, I threw a little hitch in it. If we square root 98 and 450, we don't get nice numbers. But if you did that, you jumped the gun, because remember, always look for a common factor first when factoring anything, even a difference of squares. So in this example, there is a common factor. It's not a big one. It's 2. If we common factor 2, we end up with 49x squared minus 225y squared. Now 49 and 225, we can square root. So we had to common factor first, and now we can look to square root. 49x squared, and if we square root 225y squared, 49 square root is 7, x squared square root is x. 225 square root is 15, and y squared square root is y. And we can check those on our calculator if we're not too sure. But now we've got our two terms, 7x and 15y. So we write our two brackets, 7x, 7x, 15y, 15y, plus, minus. Done. All right, that's factoring difference of squares. Now let's look at a perfect square trinomial. There was a typo in this example, and it was that's supposed to be 25. So to decide whether we have a perfect square trinomial, we have to square root the first term and the last term. So let's do that. Square root x squared, square root 25. And they both have to square root. And in this case, they do. We get x and 5. Now the middle term has to be 2 times both of these terms. So 2 times x times 5. And if we get the middle term, we've got a perfect square trinomial. And the nice thing about factoring a perfect square trinomial is it's one bracket. And that bracket's squared because it's two of the same bracket. And what's the bracket? Well, it's got x and 5 in it. And the sign comes from here. All right. Let me grab some highlighters so I can show you where all that comes from. All right. So the x in our answer comes from square rooting x squared, which is our first term. The 5 comes from square rooting the 25. And the sign plus comes from the middle term, plus. And this only works, this factoring only works if it passes this test. 2 times our answers to our two square roots has to be the middle term. If it's not, it doesn't work. Now, you can factor this way if you identify it's a perfect square trinomial. Or you can just factor as a simple trinomial, which was lesson 5.4. You can factor it like 5.4. In 5.4, what do we do? Well, x squared plus 10x plus 25. We would look for numbers that multiply to 25 and add to 10. And the numbers that multiply to 25 and add to 10 are 5 and 5. Well, so we would write two brackets that both start with x and that have 5 and 5 in it. And those 5s are both plus, so plus and plus. And now this is slightly different from this because there's still one more step. If your brackets ever end up the same from factoring, you just write it once, squared. So do you have to know how to factor a perfect square trinomial? No, you don't. You just have to know how to factor a simple trinomial. But if you recognize that this is a perfect square trinomial, you can get there faster. This was 3 lines, that's 1 line. And a little bit of side work, which you might be able to do in your head. Let's try B. We're going to factor it like a perfect square trinomial, but again, we could do it just like a simple trinomial. Multiplies to 81, adds to negative 18. You could probably figure it out. But let's try the other way. So square root a squared, we get a. Square root 81, we get 9. And if we double a and 9, do we get 18a? We do, 18a. Now this is negative 18a. All that means is that our answer is going to have a minus sign in the middle. And what's the minus sign in the middle of? Well, it's in the middle of a and 9. And there you have it. We just factored a perfect square trinomial. Let's try one last one. This one is a complex trinomial. So if we wanted to factor this one, we would have to factor it like less than 5.5 because it doesn't start with just x squared. This one starts with 16x squared. But let's try to factor it like a perfect square trinomial and see if it is one. Square root 16x squared, square root 9. What do we get? Well, we get 4x and we get 3. So is the middle term 2 times 4x times 3? Well, let's check. 2 times 4 is 8, times 3 is 24, and there's an x. So this is a perfect square trinomial. So let's factor it. One bracket, and that bracket's squared. The sign is a plus sign, and it's got 4x and 3 in it. And this would be way faster than trying to factor this question like a complex trinomial. Okay, that's it for 5.6 part 1. There's an application question, which we're going to do in the second part of our video. Thanks for watching, and I'll see you for part 2.